All right, let's roll on. So hey, everybody, thanks for coming out. I know that we've got kind of a time crunch tonight, so we're gonna keep this as succinct as we possibly can so we can get all this information to you and everybody can get down to the school concert. Again, thanks for showing up tonight. I know it's a rainy night. I know it's a Tuesday afternoon, not an ideal time to come and talk about science, but this is good, important science. I'm Ruben Cash. I'm the environmental coordinator for Skagway Traditional Council. With us, we also have our program assistant, Colton, and our new employee, our environmental specialist, Eric. If everybody hasn't met Eric, please say hi to Eric Dye. Colton's been on the project since 2021. Is that right? Ish. Yeah. So Colton's been on it since from pretty much the ground floor. You just missed the great fun, which was 2020, figuring out how to use the equipment. And Eric jumped on this year. And has had the lovely pleasure of joining us for the full fry cruise season. And then also on Zoom, we have Dr. Barclay Sive, who is a chemist for the Air Resource Division for National Park Service. And Barclay's going to be helping me to deliver to you guys some exciting news about the future of air quality in Skagway. As usual, I like to have a roadmap when I'm going through all of this stuff. So this is what you guys are going to be tortured with. And again, we'll go through this quickly. You guys understand your PM2.5, which is great, but we're still going to go over what that means in terms of the greater 10,000 foot view of air pollution, of air quality. We're going to look at the type that we're measuring. We're going to look at the health effects. We're going to look at different sources, and then we're going to look at the benchmarks that we can compare our data to, and then talk about the equipment that we use to measure it. And then you probably want to know why we did all the harebrained things that we did. So we're going to talk about our study design, which is going to give you an idea of why we set things up this way. And then we'll go over finally our results. And then we'll be talking about the future of air quality monitoring in Skagway. Everybody still with me? All right, nobody's walking out the door. That's good. So let's, before we jump too far into it, I just want to talk about the environmental department just for a half moment. We're a mighty crew of 3. That's like, oh, we have more. Thank you. Come on in, this is cozy. Okay, we're a mighty crew of 3, and everything that we do is guided by this fantastic document called an ETEP. It's the EPA Tribal Environmental Plan. And essentially what this is it's a ranked list of different tribal environmental priorities that we have identified through assessment of tribal citizens, through tribal council oversight, through staff discussions. And this is our guiding document. It helps us to implement and design these programs that are used to address these different environmental issues. And we're a busy department. You know, we're doing a lot of water quality. Of course, we do salmon in the classroom, which we're just in the middle of the throes of right now. We do stream temperature monitoring. We're doing Yukon ENA monitoring. We're watching and seeing where anadromous fishes are going. We do HAB, we do invasive species, ocean acidification, all sorts of stuff. But through a lot of different assessments over many, many years, I think over 2 decades now, concern over the effect of a typical cruise season on air quality in Skagway has been identified consistently, top priority. So in order to address this issue, we need to ask ourselves a question. What's our question? What are we actually looking at? So our question is, does the Skagway tourist season have a negative effect on air quality in the valley? Simple enough question. But to follow this line of inquiry, we need to define what we mean by air quality. So I'd like to invite our environmental specialist, Eric, to come up here, and he's going to give you the rundown. Come on down.
All right. So most of you, we talked about air pollution, but just to reiterate, the presence in or introduction to the air of a substance which has harmful or poisonous effects, such as like diesel exhaust, for example. And according to the World Health Organization, in 2019, it's estimated that 4.2 million premature deaths occurred from outdoor or ambient air pollution worldwide. And next, PM, which most of this presentation will be about, is acronym for particulate matter, the term for a mixture of solid particles and liquid droplets found in the air. Some particles, such as dust, dirt, or smoke, are large or dark enough to be seen with the naked eye. And particulate matter is defined by size, and it's measured in microns or micrometers. And just to have an give you an idea of how small they are, if you don't know, 1 centimeter equals 10,000 microns. So getting on the topic of units, sometimes units can be a little confusing. So we got a nice little word problem for you guys, and I'll read it to you. See if you guys can think of an answer for it. So if a centimeter is traveling at 30 degrees Kelvin from Belgium to Wednesday, how many bushels of apples will it take to match the length of a single inch minus the square root of 0.03937 yottameters? And at what time UTC will it overtake 1 yard of gravel traveling by hot air balloon to your uncle's house? Anybody got a good answer? Oh, yeah? Correct.
Banana.
But this is just to show how confusing using a bunch of different, it's a very extreme example, but using different units can be when combining them all. In science, we use the International System of Units, or SI units, to help communicate with other scientists in a much easier way. Here in America, we commonly use the US standard units, like inches or feet, and we're one of the only countries that do that, but just to make things difficult, I guess. And but most other countries use SI units or metric system. But scientists in the US still use SI units as well, just because of that communication to make it easy for other scientists around the world. Looking at some of the sizes, just to get an idea of what we're looking at in microns. Looking at just beach sand, they're usually around 90 microns in diameter. Human hair is around 50 to 70 microns. And then where EPA regulation begins is PM10, which is like dust, pollen, mold, things that are less than 10 microns in size. These do not stay aloft forever. They'll eventually settle. They are inhalable though and detrimental to health. Then we got PM2.5, which that'll be what we're talking about for most of this. It's from combustion particles, organic compounds, metals, ultrafine particles, often called fine particulate matter. These stay aloft. They are small enough that they could even enter the bloodstream. It's their key component of air quality index, stuff that you'll find like on your weather apps. Going into some studies on the impact of PM2.5 on the human respiratory system. That first graphic on the left shows a study by Xing in 2015, and it showed that an increase by just 10 micrograms per meter cubed of PM2.5 resulted in an 8% increase in hospitalization rates, a decrease by 0.35-year lifespan, a 4 to 8% increase in cardiopulmonary disease, and a 15 to 27% increase in lung cancer. The top right figure here shows a linear relationship between lung-related deaths and PM2.5. The bottom right figure, we're just gonna focus on part A of it, on the top left of that. The control group, the group in black there, were exposed to cigarette smoke, and the white is the control group exposed to just air. And this is an experiment done on mice. And the bacteria counts in their lungs after PM2.5 exposure were 4 times higher in the 24 hours and 35 times higher in 48 hours than the control group. And then going to the health risks of particulate matter. Poses a serious health risk because it can travel into the respiratory tract. It's especially dangerous because it can penetrate deep into the lungs and sometimes even the bloodstream, like I said earlier. Some of the health effects are decreased lung function, chronic bronchitis, heartbeat irregularities, heart attacks, premature death. Some groups that are sensitive to PM2.5, people with heart or lung disease, older adults, children, and pregnant women as well. But particulate matter doesn't just affect people, it also affects the environment. Haze is something that we mentioned earlier, and something that we can all see. It shows the presence of PM 2.5 in the air. Other effects that we might not be able to see are increased acidity in lakes and streams, foliage damage in crops and forests, altered nutrient balance in soils and waters. So it can affect a lot more things than we can just see. Now we'll move into some potential sources of this PM 2.5. PM 2.5 comes from some sort of combustion. So one thing that comes to mind right away would be the cruise ships. So one cruise ship uses equivalent energy to Skagway and Haines combined, which is pretty crazy to think about. But the cruise ships themselves, they have different things intact to clean the air that they're putting out. Now, it might affect water quality and different other things as well, but that's a different story. But all these cruise ships have thousands of guests on them, which then use things that could be other potential sources, such as the trains that run here, all the coach buses, other road vehicles, and then some other things could be industrial activity in the port, or even just wildfires called, there's some potential sources to this. So now we talked about how air quality is an important local issue. We've ID'd and defined the critical category of air pollution and its effects, and we talked about some potential sources. So what is defined by healthy air? The 1970 EPA Clean Air Act established benchmarks for PM10 and smaller. When looking at PM 2.5, it goes under two metrics: annual average and a 24-hour average. EPA has proposed changing the annual average or standard from 12 to within a range of 9 to 10 micrograms per meter squared, but not yet. As of now, it's just set to 12. It's evaluated by measuring the weight of particulate matter in a volume of air. Emulates pretty much how we breathe. This weight is measured in micrograms. To get an idea, that little teddy gram over there is 1 gram, and that's 1 million micrograms. So then going back to talk about just another sensitive group. A study in 2022 concluded that one of the more sensitive groups, children with asthma, began to experience exacerbation of symptoms with exposure to 12 micrograms per meter cubed. Reportedly, the US cutoff for sensitive groups. So regulation comes into play over 35 micrograms. However, people starting to have trouble breathing as low as 12. So just keep that in mind for the future when Ruben comes back up and talks about some of the results. So now to talk about how we measure it all, I'm going to give it back to Ruben.
Hey, thank you, Eric. So does anybody here know anyone with asthma? Breathing problems? Yeah, we probably all know somebody in that sensitive group category, and it is important. You know, we have these regulations there to protect the umbrella of all of humanity, right? But that sometimes will leave things out. So just because it's a regulation doesn't necessarily mean that it's the right regulation. These things are always in flux. So how on earth do we measure these teeny tiny little grams? You're going to use your kitchen scale? Yeah, probably not. It's probably not going to be very effective. Traditionally, in a federal equivalency or federal reference method, what you do is you have an instrument that will draw a measured volume of air into the instrument, right? And that measured volume of air contains all of your fine particulates. And then it enters into this inertial sorting impactor assembly. And I actually have on my notes the acronym WTF because I have no idea how this works. The physics are so far beyond me, but basically the idea here is that it's using it's using vortices and it's using inertia and it's using gravity and all these fun physical things to sort out these particles. We can sort the PM10 from the PM2.5. The PM10 is gonna get stuck on this plate, this impactor plate. And then the rest of it is all going to be routed down to this filter. And so you have this pre-weighed filter and you run it for a certain amount of time. How many hours would you want to run it at a minimum to reach a benchmark? Anybody? 12? 24 hour. We need a 24-hour test, right? We need to be able to figure out what the gravimetric weight, that's what it's called, gravimetric weight. Ooh, that's so exciting. After 24 hours. And so it's very, very accurate. Incredibly accurate, but it's also incredibly expensive. I mean, hundreds of thousands of dollars just to purchase this equipment. In order to have these filters analyzed, you have to follow very strict protocols, because remember, this is a little paper filter. It's going to start swelling up when it reaches a certain amount of humidity in the air. That's going to change the weight of that filter. So you have to be very, very careful when you're measuring these things. It's expensive. It's not attainable to everybody. So what does STC do when we don't have $250,000 to buy an FRM machine? We looked into a different technology called laser photometry. All right, laser photometers. These are similar. You're taking a measured volume of air, you're drawing that into the instrument, and then you're putting it through one of those WTF sorters, and you're sorting out your particles. But the difference is that instead of being routed into a chamber where it's then stuck onto a filter, it's routed into a chamber that has a laser light source and a little photodetector in it. Right. And so as that laser light starts to interact with all these particles that are in the air, it starts to diminish ever so slightly and it starts to change its angle, it refracts. And that photodetector can take those two metrics, that attenuation of the light and the angle of its refraction, and it can calculate an estimation of the mass weight. Fantastic. The best part about this is that we can do this in real time. We don't have to wait for the 24 hours to figure out what our mass weight is. We can whatever we set the instrument to, we can determine what that mass weight is. It's affordable. It's especially when it comes to calibration. If you take an FRM machine and you go and you want to get it set back to reality, to zero, we're talking tens of thousands of dollars. We can do this for a couple hundred for our laser photometer. It's really nice, but it does suffer from some drawbacks. The principal drawback to this technology is that it's relying on visual cues only. And to illustrate why this is an issue, we're going to bring up the old classic golf ball and ping pong ball dilemma. You guys have all dealt with this, right? No. Well, you look at a basket full of ping pong balls and a basket full of golf balls. Which one of those is heavier? You guys know that, right? Golf balls, obviously. Intuitively, you know that golf balls are heavier than ping pong balls. Well, poor old laser photometer doesn't know the difference. It just thinks that they're the same size, and so it's going to spit out the same weight for those two things, and that's not accurate. So this can be overcome by co-locating your machine with one of those gravimetric samplers, and then finding out, so the laser photometer is reading this, but the actual weight is this. And then you can set a calibration factor so that you know you're within a certain tolerance. And really, this is only important when you're measuring things for regulatory purposes, right? If we want to say, hey, you're polluting too much, you need to stop that, then we need an FRM or an FEM machine, and we need really, really accurate numbers. But for our purposes, we're just looking to see if there's a difference between cruise ships, no cruise ships, cruise season, no cruise season, right? We did set a calibration factor for our machine that was based on the same equipment that we're using, co-located to itself with a little gravimetric filter. So we were able to get the data set eked down close to reality. But I think we're going to bring Colton up here to talk about the equipment that we are in fact using. Come on up. Yeah.
All right, so this is the dust track machine. This is the machine that we're using for our surveys. This is what's used throughout the state, and this is to kind of fit the bill, fit the budget, and of what we have settled on here at STC. And then the study was drafted in 2018. It was assuming that every year would be a normal season, and that we would be able to get the full full amount of data that if we started a little before the cruise ship season, and then we would get the cruise ship season, and then we would get a little bit of right after the cruise ship season, and this was assumed that we would have every year. We couldn't have predicted our 2 years of plague and thus 2 years of empty town, and then mostly empty town back up to having a full town this year. But it was kind of a blessing in disguise because never in a million years would we be able to get a town without tourists in any other circumstance. So it let us get a year, 2 years of data that we wouldn't otherwise be able to get. So we were able to get this data that we would never get any other way of having a year with no ships, a year with very reduced traffic, very reduced buses. And it's just kind of a blessing in disguise these past couple of years. When it came to actually picking sites for the project, we want to avoid busy roads, obstructions, and kind of places that would just sit there and spit particles into the machines for the 24 hours that they would be running. So we kind of needed open areas that weren't directly in traffic, but would get data for each chunk of town. So we have 3 machines, and the 3 sites that we settled on are, we have a site at the bottom of the town at the boat harbor. It's at the top of the first boat ramp. You can see it from the harbor master's window. It's open there. It be seen from the harbor master's window, so it has that added layer of security with that. And we get it's right in front of the cruise ships. It's where all the boats pull out of and dock. Trains board there, buses board there. It's a nice sample of all sorts of different sources. And then in the middle of town, we have a site right outside the building here in the backyard. So, you know, protected there again, just being outside our building here. Trains board here, trains offload here, buses go down the main road. Lots of foot traffic, lots of people will be smoking with all this foot traffic. So again, we have another good site right in the middle of town with all these sources of information. And then our last site is up by the bridge across from the across from the AP&T garages. All right. Next to that power pole there at the end of town. We get right outside the train yard, lots of matter from that. Foot traffic there, all the cars that have to go across the bridge, all the buses that are constantly going back and forth across the bridge. Again, very good site for getting our 3 points of information here. And then originally our 3rd site was right here, and that got moved after a year because of skewed data. But these last 2 years, the bottom site, the middle site, and the top site have been our main spots for these past 2 years. And then looking at the study itself, it is a 24-hour test, so each site will be set up every other day for 24 hours. And the dust track itself has a limited internal battery life. It's by itself, it's meant to be indoors. So we have all this extra stuff. We have external battery to help prolong battery life. We have this case you'll see here to help protect from the elements. And with all that, I will just get into a demo. So this is what you're gonna see. I'm sure you have seen at each site, boat harbor, bridge outside here. Tripod case is gonna be what our setup looks like if you're just going past it. But coming into our case, we have our dust track itself. So as I said, it is a every other day test. So every other day we will have either set it up, and the day after is taking it down and then letting it charge and kind of offloading it that day. And then the next day it'll be back up for another 24 hours. So it's an every other day deal. And when we come in the morning on a setup day, we'll turn on all 3 machines. will take note of their starting battery percentage and if there were any issues with each machine turning on. And then we will take notes of the initial calibration, if we had to change any settings during the calibration. And then after all that, everything gets loaded into the truck, we head off to the site. And then once we get to each site, we'll open the case. We'll turn our stuff back on. This just gets plugged into the top of the machine and it does a zero cal. We'll tell it to zero cal, it'll do that by itself, it takes 1 minute. And then once it's zero, while it's zero caling, I'll usually get the tripod start getting set up. When it comes to the tripod, we have a few things here up at the top. You'll see this just screws in. And this helps suck in air, helps protect it from rain or anything else that will be falling from the top. And then we have our tube that plugs into the strike itself. This helps direct air into it. And then we have our bottle that just screws in here and collects excess moisture for so they get into the dust jack. And then by now, our zero cal should be done. And we'll have our impactor plate here. This is what's gonna collect all of our particulate matter. We will hit this with 2 drops of impactor oil. It just kind of helps get things trapped. It helps get things moving in there. This just plugs into where the zero cal plugged into. And then both this and our battery will get strapped into the case. They have their own little slots that everything just slides into. Everything has their own cords and plugs that everything is connected with. And then once we're done there, it's like for the case, we will do a survey check just on the spot, make sure everything's reading correctly, make sure it's not reading negative or if there's any errors. Once that's all confirmed, case will get closed, case will get logged. We'll finish our notes at each site, which include just air temperature, wind direction, wind speed, if it's raining, anything that's out of the ordinary that we might notices, each site will get written down. And then that's it for that site for that day. We'll go on to the next site, go on to the third site, get everything going. And then test will run for 24 hours. So we'll come back the next morning at 10 a.m. for takedown. And when it comes to takedown, it's just we will write down the minimum, maximum, and average readings that took over the last 24 hours. Get everything just disassembled there. And then that's all we do on site. We'll take the same notes again that we took the day before. And then once we have everything disassembled and we have all 3 stations back at our lab, we will offload all of the information onto a master sheet on the computer. We're just going to keep all of our days organized there that we read each day from each machine. So we'll have unit 1, unit 2, unit 3 folders and different sheets going. And I believe that's all I have.
Hey, sounds like you've done that a few times.
I've done that a few times.
So I probably don't need to go over with you guys what the importance of experimental design, right? We all understand how to run an experiment. You know, you can have control treatment, all that stuff. And as Colton was saying, there's no way that we could have been like, hey, Carnival, take the year off, right? We need to get this air quality study done. We just couldn't do that. So the pandemic was hard. The pandemic was really, really just brutal for a lot of people. But the one silver lining is that we were able to gather this incredibly awesome data set. And Jamie, I'm so sorry if these numbers are wrong. These are visitor statistics from the last 4 years. Most of this was pulled off of the municipality website all through 2022. 2023, I pulled off of a KHNS article, right? It says there were 1.2 million cruise ship passengers, biggest year ever for Skagway. I mean, that is really something. And if you look back over the visitor statistics, there is kind of a relationship between these cruise ship passengers versus total visitation. This relationship, it stays pretty consistent. So I was able to extrapolate and basically estimate that we had somewhere around 1.9 million visitors altogether. We'll see if that actually holds muster to the actual statistics. But as you can see, if we're asking the question, is there a negative effect on air quality during a normal cruise season in Skagway? We've got a great data set to be able to show that. We had almost 0 visitors. We only had about 5,000 people show up in 2020. We had a very, very small year in 2021. And then things kind of ramped up. We had this 3-quarter fry in 2022, and then the biggest cruise season in the history of Skagway. So really, really incredible data set to be able to throw together. Then here's just some photos from the different years. It's 2020 is when we were just learning how to use this equipment and all of its quirks and foibles. And let me tell you, there are a few. And then, of course, my lovely assistant, Mrs. Olga, was out there every day with me. And then here's our lone ship from 2021, the old Constellation. That was actually the moment that it first docked in Skagway. Nice and quiet year that year. And then we move on to 22, which of course was set to be kind of a good record-breaking year, but then we had to limit the amount of boats that could dock at the railroad dock because of the rock slide. And then the historic year of 2023. So all in all, this is my favorite slide of all because I get to tell you all the numbers. This is a 4-year study. We trained 10 technicians to be able to do what Colton just showed you that we did. 10 different people learned how to do this. We set these things up over 1,000 times, which means that we also broke these things down over 1,000 times, 1,033 setups. It's a whole lot. Guys, we analyzed 4.5 million liters of air in the 4 years that we've been doing this and took 1.5 million samples. This is a huge, huge data set. These guys and all the rest of our crew recorded more than 14,000 environmental observations and did more than 5,000 calibrations and QA checks. I just want to give these guys a hand for all of their hard work. Huge effort, huge endeavor. So all of these data have to get put somewhere, right? And so we put it into spreadsheet form. This is an example from 2020 of just one of our sites. This is all the data that goes into 1 year from one site, Small Boat Harbor. And the nice thing about having data in this table form is that you can then take it into a statistical program and ask it any question that you want. And that's essentially what we've done. So here are the results from our 4-year study. I'm going to show you all the data just on one slide so that you can kind of see what we're looking at. So on the y-axis here, we have PM2.5 in milligrams per cubic meter. So when you're reading this, you'll notice there's this one here that says 0.007. Well, that third significant figure is our microgram figure. So 7 micrograms is here. This would be our limit there. In fact, let's put our 35 microgram limit. There's our EPA benchmark limit. And then you're looking at the x-axis at 2020, 21, 22, and 23. And as you can see, we are not breaking any benchmarks. So that's good news. It's great that we're not dealing with highly toxic air where we need to get some regulatory action happening here. But as you look at this data set, look at 2020 and 2021, and remember that 12 microgram limit where sensitive groups start to be affected. And you'll notice that 22 and 23 puts a lot more days where there's certain people aren't able to breathe the way that they should. That would be 21 days in 2022 and 26 days in 2023. So you can kind of get some information from this, but this is just throwing all the data up on the graph. I like to look at things in terms of a box plot. Is everybody familiar with the box plot and how this works? You guys kind of know basically what's happening. It shows the whole data set, right? You got this line in the middle of it. This is the 50% line. So 50% of the data lives in the box and the others live in the whiskers, right? The bottom 25%, top 25%, and the X is the mean. So as we look at this, this is the average of all the averages for each of the years. And we can see, and we've done the statistical test on it, there is statistical significance between having basically no cruise season and having a cruise season. You definitely see this increase that's happening. So good old box plot. There was no statistical significance between 20 and 21, and there really wasn't any statistical significance between 22 and 23. But again, if you look back at those visitor statistics, And so far back, sorry, guys. You can see you can split this data set down the middle, right? You've got these 2 years where there's basically nothing, and these 2 years where there's definitely an awful lot more. So let's go on to the next fun little box plot. Remember, we threw this table data so we could do some different statistical analyses with it. And we've looked at our box plot for all the years. Well, we also split it up by unit. So here you can see I've color coded the years to be together. So you've got 2020 in gray, blue for 21, orange and green, etc. And then each one of those has our 3 sites going south to north. This is Small Boat Harbor, STC, and up on 21st. And really, there's no consistent pattern for the geographical distribution of PM2.5. At first, we were thinking STC is really the hot spot. I mean, look at the middle one and all of these. It's almost consistently that was our hot spot. But the same didn't hold true in 2023. Part of the reason I think this is the geomorphology of the valley. We're right up against the valley wall, right? So particulates could get kind of trapped here. So you could see a little hotter readings. We also have trains that pull out just right outside of the building here on a regular basis during the season. But then you see this outlier over here in 2023, the Small Boat Harbor won. And it definitely saw the highest readings. And I don't think that's because it was close to the cruise ships. The thing that changed in 2023 is they started staging coach buses about 200 meters away from our stations. So every single day, right after our machines would start logging data, there'd be 4 coach buses sitting there just kind of idling. You know, they weren't right next to it, but they were close enough in proximity that I think that may have skewed the data ever so slightly. It's hard to say. But really, like I said, there's really no consistent pattern to the geographical distribution. But one of the patterns we did notice, remember, we're out there taking environmental observations every day. Well, we're also counting the number of ships, and we're tracking and writing down the names of those ships. So if you look at PM2.5 versus ship count, we see another pattern emerging. Again, PM2.5 average on the upright, and ship count going from 0 to 4 on the bottom. So you'll see with 0 ships, there is a significant difference between that and having 4 ships, right? So we definitely see this pattern. Then cracking into the environmental data, I like this one because it's looking at PM2.5 versus wind speed. Does it make sense that we would see higher particulates on a still day? Right, yeah, and the data agree with that. Right, we've got wind speed, low to high here, and we can see that there is kind of a pattern. I mean, there's a lot of noise in the data set, but if you look at it as a whole, we definitely see that tendency for particulate matter to get blown away in the wind. And then the same thing when we look at cloud cover and precipitation. This might be a little counterintuitive because remember, the photometer is going on visual cues. So sometimes it can tend to inflate the amount of mass that's in its chamber when there's a lot of moisture around. So I would have expected the opposite to be happening here. We've got cloud cover with less cloud cover on the left, more cloud cover on the right. So the clearer it is, it seems like the more particulates we had in the air. And this makes more sense when we think about precipitation, which shows the same pattern. As the rain is falling through those particulates are getting adhered onto the rain droplet and they're falling out of the sky. And that's one of the ways that we find ourselves with acid rain, right? So higher precipitation means less particulates. And that all makes sense. So that is the preliminary analysis of the data. We have answered the question. The cruise season does have a negative effect on air quality in Skagway, but not to a huge degree. We know that we didn't break any of those regulatory limits any more than we did any other year. But what does the future look like for monitoring in Skagway? And to look at the future, we kind of got to look at the past. We're not the only ones who've been looking at air quality here in town. The Park Service has been doing work on this for the last 2 decades. Most of you are probably familiar with their lichen analysis. Well, let's back up for a second. PM2.5, is that all we have to look at? Probably not. There's 5 different components to an air quality index. PM2.5 is one of those. We also have ozone, we have carbon monoxide, sulfur dioxide, and nitrogen dioxide. These are not things that we've been measuring, but the Park Service has been investigating into this. The lichen study, they took these arboreal macro lichen plots, and they would harvest a bit and they would send it off to a lab and they would do an elemental analysis. What were they looking for? I think basically just metals, heavy metals. And then they were also doing some other sampling. The two that are showed up here, these passive samplings over a couple of different summers using ambient atmospheric pollution samplers. Those are the ones at the top you can see there in Dai. And then this one's fun. Ion exchange resin tube precipitation collector arrays. But you want one of these in your backyard? That's what these guys are here. And they're basically, they're looking for the sulfur compounds and nitrogen compounds. And to kind of sum it all up, what they found is that early on, when they were first doing the study, they saw a lot of errant mining related elements in the lichen plots, right? So some of that stuff that comes off of the ore trucks that comes down, they were seeing a lot more of that. But then as time went on, they started seeing less of this mining related particulates and more combustion related particulates, more of that sulfur and nitrogen. So really, really great information. I think there's a study that's due to be out here anytime that I'm really interested in reading and just seeing everything in a synthesis. But the issue here is that for me and you, this isn't continuous sampling. This gives us an idea and a picture of what's been happening over the last couple of decades, but we don't get that real-time data. Ideally, we would have a permanent network of monitors that were continuously sampling for multiple pollutants, you know, trying to capture those 5 of that AQI and then displaying those data on a public-facing portal. Wouldn't that be great? Yes. So back in 2022, STC and the Park Service applied for a grant through the EPA, the Air Quality Monitoring for Communities grant. And we were one of 4 awardees in Alaska. We got $500,000 to set up this new air quality array. And so we're leveraging equipment that's already in place and equipment that needs to be in place. So if we look at the map here, you can see that yellow triangles are our 3 spots that we sampled. Green triangles are where the Park Service has deployed purple air monitors, and the red triangle is where the municipality has deployed purple air monitors. And so all of these triangles are actually up and running now, all pulling data and putting it into one central place. And what we're planning to do is we're going to expand this capacity, and we're going to bring in some new instrumentation. They're going to be looking at all of these different compounds, including meteorological data, so that we're not just having this categorical observational data taken one time per day that really will give you weird results. We're always going to know what the wind speed and the temperature are, all that stuff. And then all of these different parameters are going to be measured. And to explain a little bit more about this, Barclay, do you mind jumping in here and explaining the things that I can't necessarily explain?
Sure. And I just wanted to make one more comment about getting funded. I mean, this was a huge undertaking, and you know, the fact that, you know, we collectively were able to land one of these EPA grants was really a big deal. So I mean, the Park Service is really excited to be working with the tribe and the municipality. So this is, you know, this is really I guess the best word I can come up with off the cuff is exciting. And, you know, we are, we sort of designed this off of an existing network that the Park Service uses in Hawaii, but what we're going to deploy up in Skagway there is, I think, you know, it's kind of a state-of-the-art measurement suite with a combination of federal equivalent methods, so FEM for things like NO2 and ozone, coupled with, you know, state-of-the-art sensor-based measurements, which have come a long ways in the last 20 years. I've been doing sensor-based, or I dabbled in sensor-based stuff about 20 years ago, but just the improvement in the materials and technology have allowed for, you know, more robust, cheaper ways of doing these things. So now we can have reliable, real-time measurements of key atmospheric constituents that are, you know, some of which are regulated by the EPA, which include things like CO, ozone, NO2, PM, and SO2, all of which we will be measuring as part of this. So use it, you know, up on the screen here, the AQ sync is based in the federal equivalent method, so we can sort of really tether things to reality, to make sure that all the sensor-based measurements, so the AQ light, the PAMs, the purple airs, the dust tracks. Actually, the dust tracks kind of get combined with the AQ sync in the sense that that will be a way that we can ensure that the optical based techniques like that are used in the purple air are accurately reflecting the true PM composition of the atmosphere. Um, so I think we're all very excited to, you know, we're waiting on the equipment right now. It's almost ready to go. Once that happens, we'll um, acceptance test it down here, get it shipped up there, and set up and going. And I guess we can go to the next slide. Again, just to give folks an idea of what what we are doing. This is the Hawaii Volcanoes Air Quality Alert page. And I just wanted to quickly show a couple things because, you know, we've been fortunate to be able to operate this because, well, Hawaii Volcanoes, in case you aren't aware, it's one of the only places, well, it's the only national park you can go to and effectively die from breathing if you don't have a rescue inhaler in hand. So that's where we came up with sensor-based SO2 measurements and PM measurements for an air quality alert system. In this case, you know, we've got the map with the colored dots on there to reflect what the air quality is. And then we also have sort of the bar chart plot on the right there, which gives you SO2 concentrations in 15-minute intervals, because for health-based related reasons, you know, you get a burp of the volcano and you can actually see I took this off the web this morning. There's actually a couple orange bars in there. So you do get a little whiff. And again, depending on which way the wind is blowing, so we have meteorology coupled in here with this, you know, you're able to ensure people are aware what is going on and what are the levels. So next slide. And again, just to give an idea of, you know, we've deployed these things, and I kind of wanted to show this because, well, that was the last time we had we actually saw the volcano. This was right before the 2018 eruption. And then it went away for a while. Now we can see color in the crater. But what I wanted to show is that, you know, data from sensor-based, we have PM and SO2 traces there, just showing an event. But what I wanted to also show is, you know, we have these tripods using solar panels with batteries, and inside them we have the sensor-based, you know, in this case, we pair up SO2 sensors to ensure that what we are measuring is in fact, again, accurate. And this is all, you know, recorded and reported in real time. So next slide, please. And so just to give people an idea of, and you know, this really, it's already quite interesting what we've been seeing so far. So this is the working prototype that we already have going with the 10 purple airs being deployed. And this was just an event in November where you can see you're going from clean to sort of intermediate to, you know, a lot of stuff going on. And this, sort of reinforces what Ruben was talking about in terms of, is there homogeneity throughout the valley there? And by being able to spatially deploy these sensors, they don't always all track each other all the time, which, makes sense because air masses have different compositions, and as they are transported in and out of the valley from air to sea, land, breeze, you do see differences, but just from what we've seen thus far, and I've got November here. I should have pulled up some of the cruise ship stuff too, but it's very encouraging. And, we will be sort of communicating more with the citizens there of Skagway, because we want to have an interface that is useful and informative for everyone. So I will stop there because I can keep talking about this stuff for hours. We're already approaching the top of the hour, so I will stop there. Hand the mic back to Ruben.
Awesome. Thanks, Barkley. Really appreciate it. Working with Barkley has been outstanding. A lot of this is way outside my wheelhouse. I'm a fish guy. Air quality was like, what? Air quality? I've never dealt with this stuff. So it's been really helpful having kind of a guide to come through this. He's been really helpful writing the quality assurance project plan, which was a tier 4, which is like as difficult as it gets. Really, really excited about this project. One of the things we're really excited about too is that we wrote in to the budget the ability to buy some of these e-bikes. Anybody who's ever tried to drive down Broadway in the middle of the summer knows that it's difficult. I think with these things we'll be able to bob and weave and sneak in, plus it's 0 emissions. We'll be able to do all our calibrations for the air quality array with that. And we will be holding more community outreach as we get closer to rolling out this new array. We do want your feedback. We want you to tell us how the website's working. What are some parameters that are missing? Is there any functionality that's not there for you? We want to know this. So please keep your eyes peeled for some of these next outreach events. We're hoping in the next couple of months, we'll get the instrumentation acceptance tested and here to Skagway, and then we start deploying. So it's coming up, you guys. It's really exciting. And with that, here's Gumbo's butt. If anybody has any questions.
When you originally started this planning in 2019, isn't it?
2018, actually, yeah, and I wasn't even part of it. The original author of this study is here with us. Nicole's here.
So at that point, you weren't expecting, and before you even started, you weren't expecting to have the pandemic to give you this data set point.
Right.
Now that we have the cruise or the ore work going on, was that something that you kind of expected, or I'd imagine you expected it at some point recently, but are you excited to get this new data set from the winter of all this activity with 4 or 5 cranes and extra tugboats and
Definitely. Yeah, we don't have our dust tracks running, but the purple air system is up. And so that'll capture that PM data. So yeah, I think it's going to be very interesting. I also think it's going to be interesting to see how the valley does with the wood smoke, because we do have a tendency to see more inversion events during the winter time than we do in the summertime. And those inversion events are when cold air is trapping the warm air down kind of at ground level. So all that smoke, all those particulates get caught down here where we breathe. And I think that's probably one of the things that we were looking at here on this. I want to say that we got really, really cold somewhere right at the end of October there, right? So it makes sense to see all of these spikes there, because that's when everybody's firing up their wood stoves. And along with that really, really cold air, we could have seen some inversions. There's all sorts of stuff that I think will be interesting for a wintertime perspective as we're moving forward. So definitely very excited. Chat message. All right. Thanks, Denise. Yes, and I'm working on the final paper report right now. I just want to make sure all my stats are up to snuff, and I have to go through all the QA on the data set, go through and remove outliers and all that stuff. But I am expecting to have a written paper report within the first quarter of 2024. So keep your eyes peeled for that as well.
Ruben, where can people find the recording?
Oh, the recording will be on the STC YouTube channel. So just look up Skagway Traditional Council on YouTube and you should see it there. Hopefully there won't be too much editing because I've gone through the rigmarole of removing extraneous videos from the recording. So hopefully this will be posted pretty quick. Right. Well, thanks everybody for coming out, getting yourself to that concert, and we'll see you the next time. Thanks again, Barkley, for joining us. Really appreciate your insight, your expertise. And we'll see you all the next time.
You bet. All right. Have a good one.
All right, you too. We'll talk to you soon.
All right. Bye-bye.